Hello student, in this video we discuss the problem number 4 of type 1, that is the last problem of type 1. So what is the problem? Design the finite state machine for the language which read a binary string over the input 0, 1 and accept the string if its decimal equivalent is divisible by 5. So just read out the question carefully. What is the question? What is the problem? Problem is that the input set of the language is 0. Means the string of this particular language is a binary string, that combination of 0, 1, and the binary string is accepted by the finite state machine if the decimal of that binary string is divisible by 5. Means it is similar to previous two problem. The logic is exactly same, means you use the same logic, but there are two tasks here. First, you find the decimal of the particular binary and then divide that decimal by 5, and if the remainder of that dividend is 0, then we say that the string is accepted by the machine or the string is rejected. Got it? So what is the concept? So like that, just if we write down, the string is 1010, like that. That is the string. Got it? So just find the decimal of this string 1010. What is the decimal? So you should remember, you should first find the decimal. So you should know how to find decimal from the binary. So the string 1010 in the binary, when you convert it in the decimal value. So what is the decimal? So the decimal of 1010 is 10. So you just say the first digit is 2 raised to 0, plus for second digit you find 2 raised to 1, 2 raised to 2 and 2 raised to 3. Got it? Means 2 raised to 3 into digit plus 2 raised to 2 into its digit. So that digit is 0, plus 2 raised to 1 into its digit, that is 1, plus 2 raised to 0 into its digit, that is 0. So that 0 multiplication will 0, it is 0 0. Got it? So 2 raised to 1, that is 2, and 2 raised to 3, that is 8. So 8 plus 2 is 10. Means in decimal it is also 10. Got it? When you find the decimal value of this digit, then it will 10, and 10 is divisible by 3. You can find 10 mod 5 is 0. Got it? So means the aim is that just find the decimal of binary string and then divide that decimal by 5, and if that decimal is divisible by 5, then we say that the string is accepted by finite state. Otherwise the string is rejected. That's it. Got it? So like if we write the string like 1100, I write this string. Now what is the decimal of this string? So you should know how to find the decimal. Got it? So there is not any need to find the decimal always. Got it? We just need to find the decimal when we construct the machine. After constructing the machine automatically detect the decimal. Got it? But initially we should know. Got it? Initially we should know. So 1100. So that's 0. 2 raised to 0. That is 2 raised to 1. That is 2 raised to 2. That is a method to find the decimal. So I think you know how to find the decimal. So 2 raised to 3 into 1, that is 8, plus 2 raised to 2 into 1, that is 4, plus 2 raised to 1 into 0 is 0, 2 raised to 2 into 0 plus 0. So 8 plus 4 is 12. So decimal value is 12. The binary of 1100 is 12. So it is not divisible by 5. Not divisible by 5. So it is reject. ये रिजेक्ट होगी आपकी और ये स्ट्रिंग आपकी क्या होगी? एक्सेप्ट. Got it? So the logic is clear. Now what is the exact way to design the finite state machine? So again the same logic that we use in the previous two problem. What is the logic? If when you divide a number by 5, then how many different remainder is generated? How many different remainder are possible? When there are two ways to solve such type of question. There is one way, direct way, that we also discuss that way, but you should know what is exact logic. That's why we first solve by logic and then we check directly. Got it? So just see, in this case, the divisible by 5, when you divide any number, when you divide any decimal by 5, then how many possible different remainder? So there are 5 remainder when you divide any number by 5, then there are 5 possible remainder. Okay, so we just write down this statement. If we divide any decimal by 5, then there are 5 possible reminders. There are 5 possible remainder. So what is that remainder? That is 0, 1, 2, 3, and 4. There are 5 remainder. So if we divide any decimal by 5, then there are 5 possible remainder. This logic is valid for every case. When you divide by 6, then remainder is 6, 0, 1, 2, 3, 4, 5. When you divide by 7, then remainder is 7, 0 to 6. Got it? So it is same for each case. So when you divide the any number by 5, then there are 5 possible remainder, and each remainder is become the state of your finite state machine. So for the remainder 0, we said it is q0 state. For remainder 1, we say it is q1 state. For remainder 2, we say it is q2. For remainder 3, it is q3. And for remainder 4, it is q4 state. There are 5 state of your finite state machine. So that point is directly clear. How many state in the machine? So there are 5 state in the machine. Now you just adjust the transition of the input 0 1 on each state, and the machine will automatically create. So the logic is exactly same. Again, I said that logic is exactly same that we use in previous two question. Got it? So that is q0. Now, first, what is the initial state and what is the final state? So what is the minimum string that you accept in this particular, in this question? The question is that binary string, the input is 0, the input set is 0, input set is 0. Got it? So what is the minimum string of 0, 1 whose decimal is divisible by 5? So if you write the string null, again, if you write the string null, here is final state is fixed. Final state is q0 because the state whose remainder is 0 is definitely final state, because the remainder is 0 means that particular string is divisible by 5, whose decimal is divisible by 5. That's why it generates the remainder 0. That's why q0 is final state. But for the initial state, we should know what is the minimum string. So the string null contain nothing. There is not any 0, there is not any 1. So if there is not any 0, 1 in this string, means the decimal of decimal of null is 0. Got it? 0 decimals. It generates 0 decimal. So when you find the 0 mod 5, that will be 0, means state q0. Got it? What is 0 remainder is a final state, means null is accept. And when null is accept, means initial is, that means q0 state is a initial as well as final. This initial as well as initial and final. Got it? So just see here. Each reminder. So q0, q1. Again, I said there is a direct way to construct such type of question, but first understand the logic and then use the trick. The input is 0, 1. Is the input. We design the table, transition table. That is the state. So state q0 is the final state and q0 is the initial state. final we design the star. So initial and final is same, that's why arrow and star go to the Q0 state. So the reminder that is 0, Q1 reminder is 1, Q2 reminder is 2. We should know about that. Only on that condition we can possible to design the automata. So there are 5 states, just write down all the states. Q0, Q1, Q2, Q3 and Q4. We just write down all the states. Initial state is Q0, final state is Q0. So just see here, when you applied input 0, the input string is 0, single 0. So what is the decimal? What is the decimal? Decimal of 0 is also 0. Definitely. The decimal of 0 is also 0. So 0 mod 5 is again 0. Means the input string is 0. That is the input. It is the input. It is in the binary form. And when you convert this input into a decimal, that is also 0. So it is in decimal form. And that decimal number, when you divide this decimal number by 5, then remainder is 0. Means you go to those states whose remainder is 0. So on which state the remainder is 0? That is Q0. Then means when you apply input 0 on Q0 state, when you apply input 0 on Q0 state, then you reach on Q0 state. So that is the self loop of the input 0. So what you understand? What you understand for this particular point? So you understand that if there is any number of 0 initially, that decimal is always 0. We know that in binary, if you write any number of zeros is in the binary, then its decimal is always 0. And if the decimal is 0, then it is 100% divisible by 5, and if it is divisible by 5, then it 100% accept. That's why on the input 0 we write the self loop on Q0. Got it? So Q0 is accept all zeros. Now what is the string when you apply the input 1 on the state Q0? So when you apply input 1, so the string becomes 0 1. So string becomes 0 1. If you read number of zeros, you can possible to read the number of zeros, and after that 1 is come. So if you apply any number of zeros before any binary string, there is not any changes in the decimal. So you can directly write down, either you can write down number of zeros and 1, or you can directly write down 1. So if this is in the binary, if this is your input, then the decimal of this is also 1. In binary 1, decimal is also 1. So 1 mod 5 is 1. That means Q1 state. Means when you apply input 1 on Q0, it goes to the Q1 state. That's it. Q0 0, that is Q0 Q1. Now on the input Q1, input 0 on state Q1, what happened? So when you apply 0, so just read out the complete string from initial and find the decimal of that binary string, and then divide that decimal by 5, and if it is divisible by 5, then accept. Means if it is divisible by 5, then it goes to Q0. Otherwise it generate any reminder, and that reminder is set to any state. So just see here, just rough this particular thing, that point is clear to you. So just see here, what is the input to reach on the Q1? That single one. When you apply single one, you reach to Q1, and after that the input is 0. So 1 0 in binary. What is the decimal of 1 0? The decimal of 1 0 is 2. You should again I said that you should know how to find the binary to decimal. So in binary 1 0, convert decimal 2. So 2 mod 5 remainder is 2. Means you go to the state Q2. So on input 0, you go to the state Q2. Exactly when you apply input 1. So from initial state, the input is 1 to reach Q1, and after then you apply 1, so the string is 1 1. 1 1 in binary, convert to decimal, then it is 3. The decimal of 1 1 is 3, and 3 mod 5 is 3. that is Q3 state. So on input 1 it goes to the Q3 state. So it is Q2 and it is Q3. On 0 input Q1 goes to Q2, 1 input Q1 goes to Q3. Now on Q2 state, when you apply 0, so complete string, what is the string to reach to Q2? That is 1 0. On 1 0 you reach to Q2, and when you apply 0 it becomes 1 0 0. That is in the binary. When you convert, so 100 is 4 in decimal. Got it? So the decimal of 100 is 4. So 4 mod 5 is 4, means it is Q4 state, because 4 is remainder of Q4. That's why it goes to Q4. Now 1, when you apply input 1, so what is the complete string? 1 0 1 0, and after that from 1 0 you reach to Q2, and when you apply input 1 in binary, it is 101, in decimal it is 5. So 5 mod 5 is 0. So the remainder is 0. So on the input 1 it goes to 0, because you directly understand 101 is 5 and 5 is divisible by 5. So decimal is divisible by 5, that's why it is accepted. So on input 1 we just transfer this transition to the Q0 state. Got it? Just right down in between, that is this. Now again for what is for Q3 and Q4. For Q3 and Q4, I think you understand. So you should pause the video and you should solve by yourself and then cross check. On Q3, if you apply the input 0, so what happened? So the input 0 on this string state, if you apply 0, so the string reach to Q3 is 1 1. From initial to Q3, the string is 1 1. And when you apply 0, so the complete state 1 1 0. That is in the binary. What is the decimal? So 0 1 2. Got it? So that is, what is this? So in this case the decimal is 6, and 6 mod 5, the remainder is 1. When you find the when you divide 6 by 5, then the remainder is 1. Means on input 0 from Q3 state, the transition goes to Q1 state. On input 0 it goes to Q1. So just the table also. So for Q2, on 0 input it goes to Q4, on 1 input it goes to 0. Q3, on 0 input it goes to Q1. On 1 input, so when you apply input 1, so to reach Q3 state the input is 1 1, and when you apply input 1, complete string is 111 in the binary, that is 7 in decimal. So when you divide by 5, then the remainder is 2. Hence on input 1 it goes to Q2. On input 1 it goes to Q2. So that is Q. Now on input 0 to Q4 state. So what is the string to reach to Q4? What is the string to reach to Q4 state? To reach to Q4 state, the string is, to reach to Q4 state, the string is, you can use any direction. Q4 state, it is 100. So to reach to Q4, the string is 100. And when you apply 0 on this, so it becomes 1000. That is equals to 8. And 8 mod 5 is 3. When you divide 8 by 5, then the remainder is 3. Means on input 0 from Q4 you go to the Q3 state. And if you apply input 1, so 100 to reach this state Q4 from initial, and then you apply input 1, the string become 1001, whose decimal is 9. And when you divide 9 by 5, then the remainder is 4. Remainder 4 means the state is Q4. Got it? So when you apply input 1 on Q4, then the output transition end on Q4 itself. So there is a loop of 1. So it is Q3 and it is Q4. That is a complete table. So just see here, that is a complete transition diagram and transition graph. Like, got it? Finite state machine graph is here. So that is the way to solve the question. So any dividend, if the question is given that design the finite state machine for divisible by 7, so the remainder is from 0 to 6, and you can use same logic and design. So here, what is the direct way? What is the direct way? So direct way to solve. No need to design anything. Just write down. We know that divisible by 5 means 5 remainder. For each remainder, there is one state Q0, Q1, Q2, Q3, and Q4. Got it? For each remainder. Okay. What is the remainder? Remainder 0, remainder 1, remainder 2, remainder 3, and remainder 4. For each remainder, there is one state. So just find the total number of remainder for the given problem. So in this problem, the question is that the decimal equivalent is divisible by 5. So there are 5 remainder, 0 to 4. And we know that the initial state and the final state is Q0. That is fixed. Now, the input is 0, 1. It is also, we know, binary string. So that is the state and that is the input. Now, just in this case, just see here, total number of state is Q5. So you just write down Q0 to Q5 starting from this, means just write down Q0 here and then Q1 here, then Q2 here, Q3 here, now Q4 here, and Q, that is the last state of this particular transition. So 0, 1, 2, 3, 4. So all state complete. Now again from next cell start from Q0. Write down Q0, Q1, Q2, Q3, Q4. That's it. So the transition table you can directly design without any logic. So you can cross check here. Just see Q0, Q1, Q2, Q3, Q4, Q0, Q1, Q2, Q3, Q4. Exactly same transition table that you directly design. There is not any need to design this automata and then cross check this. But you should remember the logic if there is a theoretical question and there is a 5 marks question, 8 marks question. So you should design all the terms. You should write down all the steps. Got it? That is the way. So this is divisible by 5. Decimal equivalent of binary. Equivalent of binary. Decimal equivalent of binary divisible by 5. Same for divisible by 7. For same divisible by 7. If the question is divisible by 7, then what happens? Just see here. Divisible by 7 means the remainder is Q0, Q1, Q2, Q3, Q4, Q5, Q6, 0 to 6. For 5, 0 to. For divisible by 5, the remainder is 0 to 4. For divisible by 7, the remainder is 0 to 6. The input is 0, 1. So just write down, start from Q0, Q0, Q1, Q2, Q3, Q4, Q5, Q6. That's it. Again, Q0, Q1, Q2, Q3, Q4, Q5, Q6. That's it. That is complete. It is the initial and final both. So you can use this logic, this shortcut for each and every divisible question for the decimal equivalent of binary. Got it? Thank you.